A spoonful of plastic may not seem like a lot on its own, but what if I told you that a recent scientific study found that we have this same amount of plastic, but in our brains?
Over the years, microplastics, a word you probably started to hear more, they've been found in almost every organ in the body, as well as in the bloodstream. But now, for what seems to be the first time, these microscopic pollutants have been found in tissue in the human brain.
According to researchers, the amount of microplastics in analyzed brains rose by about 50% from 2016 to 2024. It means the average brain could contain about 7 grams of microplastics, which is roughly the same weight as a plastic spoon.
And while our brain may be the most concerning place that we found these microplastics, it isn't the only one. They've also been found in male reproductive organs and even the placentas of pregnant mothers. And when you look at all these studies, you notice there's one person who seems to always be wherever microplastic research is happening.
Microplastics are the broken down degradation product of these big products that we use.
That's Matthew Campen, a University of New Mexico professor and one of the world's leading researchers on microplastics.
This is my prop. As long as it's a fresh bottle, it's not really a major concern. It will eventually sit in the sunlight, heat, and oxygen in the air will break down the chemistry very slowly.
But break it down into what exactly? I mean, what in the world does something like a piece of microplastic, or more accurately nanoplastic, actually look like?
You get down to the nanoscale, and this is what we're working on now. They seem to be more like these flakes or shards, and they're roughly the size of viruses in the 200 nanometer range. And what we see inside the human body is almost exclusively that kind of plastic.
If this wasn't bad enough, it also seems like the amount that's being discovered inside of us keeps increasing.
Absolutely. It's almost a no-brainer, though. That rate of change of 50% over 8 to 10 years is kind of in line with the dramatic increase in plastics that we've produced on this planet. We double the production every 10 to 15 years, and now there's 1 ton of plastic for every human on Earth.
If you think that a spoon's worth of shards swirling around your brain and increasing every year sounds bad, well, you're probably right. But the problem is that we don't know how bad exactly.
In every disaster movie, there's some nerd who has calculated a time frame before disaster hits, whether it's Jeff Goldblum is saying, hey, in a few hours, these aliens are going to shoot their cities. Or if it's Leonardo DiCaprio saying, we've got a couple months before that comet hits the atmosphere. Okay. The problem with where we are now is this is going up, but we don't know when it becomes a disaster. And so it creates a level of concern and anxiety because of the not knowing.
From the University of Chicago Podcast Network, welcome to Big Brains, where we explore the groundbreaking research and discoveries that are transforming our world. I'm your host, Paul Rand. Join me as we meet the minds behind the breakthroughs. On today's episode, how microplastics are invading our bodies and what they're doing in there and how we can stop it. The University of Chicago Leadership in Society Initiative guides accomplished executive leaders in transitioning from their long-standing careers into purposeful encore chapters of leadership for society. The initiative is currently accepting candidacies for its next cohort of fellows. Your next chapter matters for you and for society. Learn more about this unique fellowship experience at leadforSociety.uchicago.edu. So chances are anybody listening to this podcast has microplastics in their bodies. And now the question is, well, how in the world did they get there? And even more importantly, are they worrisome? And you mentioned a moment ago that one of your first study was looking at pregnant women and actually specifically in the placentas. Tell us about that.
We first explored a study with the help of colleagues at Baylor College of Medicine, Dr. Shirsti Agard and Enrico Barroso. They shared with us these placentas from a wonderful repository they have. We measured the plastics with our method here, which is a analytical chemistry approach to quantify the total amount of plastics. And, we saw some. But Enrico has a paper that's in preprint form now. He's presented it at the Society for Maternal and Fetal Medicine. But he found that the amount of plastics in placentas from preterm birth are about almost double the amount that are in full-term birth. So even though those placentas had a month less or more time to accumulate the plastics and ultimately led to a premature birth, they had quite a bit more plastic in them.
Well, and the inevitability of this, of course, if it's in the placenta, it means it's coming from the mother into the unborn child.
Right. And we're exploring this now to sort of better understand the degree to which they do penetrate through the placenta and get delivered to the fetus. And then to understand, are there study opportunities where we can, take placentas from healthy deliveries and then use that as a metric and then follow the development of those children? Do they grow normally, develop? Do they learn? Are they socially normal? All these questions that I'm a parent. I worried about all these things with my kids.
Yeah, I bet.
So yeah, when I was born, there were probably no plastics in my brain. It's been a while, right? But kids today are born with plastics in their brains.
Well, and not only in their brains, but likely in other parts of their bodies too. And another place that you also did some research is you found, at least in males, human males and dogs, that they're very prominent in the testicles.
Absolutely. Kind of interesting that there were 3 times as many plastics in the testes of humans compared to dogs. You think about dogs eating off the floor, chewing on plastic toys. Yeah, that's probably not the main source of uptake. I think it points to the human diet. Foods we eat may be a major source of this.
The other part that really stood out to me was, especially when we talk about the plastics in the testes, is that the declining rate of or increasing rate of infertility, and that the idea that sperm counts have really plummeted 50%, if I recall, over the last few years globally. Does this have 50% is a staggering number, and in a period where every time you turn around, we're having billboards going up about having more babies. How concerning is this beyond where that number could actually grow to, and what the implications could be?
Absolutely. So, I think the time frame is over our lifetime, right? So I think in the last 50 years, the global sperm count has dropped about 50%. Nobody knows why. I remember back in the 80s, we were saying, oh, it's tight jeans or it's hot tubs. But here we are. It's still happening. It's easy to point the finger at plastics. We need to learn more. Right now, I'm working with a colleague, John Yu, Dr. Xiaozhang Yu, in our College of Nursing here at the University of New Mexico. And he has very compelling data now, expanding from that original study, that does show sperm motility is decreasing with increased amount of plastic in the testes.
Well, the other is we're taking through body parts here. The one that you've also recently gotten into is the brain, and you mentioned that a minute ago. And now it's getting even more concerning, at least to me, of different body parts that are being impacted. We'll talk about this relation to dementia and Alzheimer's and other areas. But tell me about the study that you did of looking at microplastics in the brain and why that's setting off alarm bells for you.
Well, I think it's very personal for everybody. The brain is what sets us apart. We cherish our brain. We think highly of our intelligence, and our brain contains our personality and our emotions. And we're now hit with this idea that there's something in it, inside of our brains, that we did not want there. We don't know that it's detrimental yet. The point we discussed earlier about how it's going up over time, right, is the real cause for concern. One of the discoveries we've had lately that's not published is that where we were sampling from, which is the frontal cortex, that seems to be the highest amount in the brain, concentration-wise. The rest of the brain still has some, but it's less. So,
and can you tell folks, again, what is typically happening and being controlled through the frontal cortex?
Sure. That's our executive region. So a lot of our thinking and decision-making is going on up there.
It does show up, as you mentioned, in other parts of the body, kidneys, other areas we talked about. Why is the brain a hot spot for collecting microplastics?
Well, part of it is that the brain is not a clearance organ, whereas the kidney and the liver are kind of designed to handle things and get rid of stuff. The other part is that the plastics are lipophilic. The analogy I like to use is if you've ever cleaned a Tupperware bowl that had like bacon grease or fat,
Yep.
butter in it, you know it's going to take a lot of soap, hot water
Yes.
to get that clean, right? So
Unless you're
lipids-
using Dawn. If you're using Dawn, it'll take it right out.
sponsored by Dawn.
Yeah, exactly.
That's right. So we think that because the brain has the myelinated regions, especially in the frontal cortex, that's a lot of lipid. It's not what we think of as fat, like fat around your belly, but they are lipids. So we think that the plastics, especially these nanoplastic shards, are kind of getting trapped or packaged within the brain as a result of that relationship.
Okay. It's the inevitability of now thinking about this, and we've had plenty of discussions on this show about dementia, Alzheimer's, other components of it, mind, personality changes, and so forth that are coming out of this. My thoughts start running to what role are these microplastics having? I'm assuming when Dr. Alzheimer came in and concocted this theory that microplastics were not an issue. So it didn't created by this, but it seems inevitable that or undeniable that Alzheimer's and other forms of dementia are getting worse.
Are plastics making things worse, or are they counteracting some of the advancements we're trying to make in therapy and medical care for people with dementia? That is a very difficult question to suss out. There's some nice studies. Andrew West from Duke had done a study showing that little nanoplastics can cause the aggregation of synuclein, which is more associated with Parkinson's, but is also a part of the neurodegenerative outcomes that you see in dementia. There's a more recent paper looking at amyloid beta.
Yep.
And the same idea. These plastics might cause the aggregation or accelerate the aggregation of these really detrimental proteins.
Now, your study showed that patients with dementia do have up to 10 times more of the plastic in their brains. So there seems to be, obviously, somewhere there's a correlation in one way or another here.
And we're hesitant to jump to any kind of causality because the study design, it's very possible that the Alzheimer's brain is just a more hospitable environment for these to land in. One of the things we noticed was there seemed to be a lot of these refractile particles that we think are plastics all along the blood-brain barrier. And we know that in the dementia cases, the blood-brain barrier is typically impaired. So it could just be that these are passing through more readily and getting stuck there in the inflammatory regions of the brain.
Are there other implications that we also speculate dementia may be playing, i.e. inflammation, that the plastics are causing inflammation in some of the vessels or otherwise that we're also looking at?
It's interesting. Latex and polystyrene, they don't create a great deal of an immune response, even when you put them directly on immune cells in culture. I honestly think our body doesn't respond that well to them, and that's part of why they accumulate.
Interesting. Okay.
I think that they hijack their way in with the lipids that we eat. So I think that these plastics are incredibly well disguised. It's like they're wearing a cloak of invisibility inside the body. And so the immune cells are not necessarily getting activated by them. But then fast forward to the degradation process. Is it possible that there are things coming off of the plastics within those contained units that do look alarming? Are they looking like oxidized lipids that are known to trigger atherosclerosis and blood-brain barrier deficits? So I have a vivid imagination, but I don't have a lot of data on this.
I don't imagine there aren't some people that say, Matt, this is just inaccurate. It's hooey. Your research is flawed. There is no problem. Are you running into that?
Oh, yeah. It's fun. I've never been in this world before.
Bet.
So it's frustrating to see these armchair quarterback scientists say, well, that's junk. That method doesn't work. This is overinterpreted. Like, no, you get into the lab and you do the work and you show us, you innovate. Like, maybe there are no good ways to measure plastics in the body right now. So please go figure it out. Like, show that I'm wrong. That's great, but innovate,
So you would expect that from public naysayers, but the question is, where are scientists coming and saying you're wrong? Those they're probably not a whimsical, emotional reaction. I'm sure they're pointing to something that, in their mind, has some substance to it.
Oh, sure, and a lot of that we acknowledge even in the paper. So the method we use is pyrolysis gas chromatography mass spectrometry, and it is the current best way to cumulatively measure a lot of polymers, but it is vulnerable to things like interference from lipids, as I discussed earlier. So it's possible that there are some lipids still in our system, in our analyte, that are looking like polyethylene, but they're not looking like polypropylene. Nobody's ever reported that. They might look like polyvinyl chloride, but there's 6 or 7 other polymethyl methacrylate and nylon and things like that. There's no way that that interference is happening. So the forest for the trees is we're showing plastics. Whether we're exact, we think of like the speed of light as 3 times 10 to the 8th meters per second. That is a very exact physics measurement. I don't necessarily need to be exact with how many plastics are in the brain. What I need is a consistent relative marker so that I can do associations with disease in a population. An analogy would be like if I had a scale that was always 15% wrong, sure, you wouldn't know exactly how much you weighed, but
right.
I could use that to discern between people who are obese versus people who are not, right? So yes, there's been a fair amount of international heat for the research we've done, and it keeps me from sleeping some nights. Yep. Honestly, it does affect you, but I will say, cool, like bring it on. Let's all put our heads together and figure out how to do this better.
So it appears as though these things have made their way through our bodies. The question now is, how did they get in there? What are they doing? And is there anything we can do to get them out? That's after the break. If you're getting a lot out of the important research that's shared on Big Brains, there's another University of Chicago Podcast Network show that you should check out. It's called Capital Isn't. Capital Isn't uses the latest economic thinking to zero in on the ways that capitalism is, and more often isn't, working today. From the debate over how to distribute a vaccine to the morality of a wealth tax, Capital Isn't clearly explains how capitalism can go wrong and what we can do about it. Listen to Capital Isn't, part of the University of Chicago Podcast Network. The question that I'd love us to dig into, and I'm sure, again, as folks are listening, you're getting the understanding here. Now we're getting into, well, gosh, this does not sound great. How do these things get into my brain? And I look now and I'm realizing I'm drinking from a blue plastic cup as we are having this. So I may be answering my own question of how these microplastics are getting into our bodies.
Where did I put my prop? These fresh plastic bottles, I like to argue this isn't a problem for you, it's a problem for your grandchildren. You can empty this thing and refill it 10,000 times, and the mass of the plastic bottle won't change perceptibly. But eventually, the entirety of this will become microplastics once it gets into landfill. So we think that the pathway is an agricultural pathway where these particles of plastic are low density and they float in water. But we take this water that's got floating plastics and we put it on our crops. And it builds up in the soils, and then we feed it to livestock, and we put the manure back on the, like we're just aggregating and amplifying this in our food pathway. And we do have some data that suggests that more processed food is worse for you. So, sausage or processed meat products may contain more plastics. That to us seems to be the most logical explanation for where these are coming from.
There is a hope, I'm assuming, that most people have is that, well, they'll wash out. They'll process in the body and wash out. Do they?
One of the things we saw, which gives us a little optimism, is that these didn't seem to accumulate with age. They go up over time from people who died in 2016 to people who died in 2024 in our sample. But if you look for people who are 18 years old versus people who are 72 years old, there was not a clear indication that was going up. It does suggest that your body takes these in, but also eliminates them somehow, or that they degrade and break down inside our body.
How long until I get to my Walgreens and I can take a pill called Microplastics Be Gone?
So this is the Wild West now. I know there are companies that are built around the therapeutic plasma exchange model, plasma apheresis, where it's almost like dialysis. And that probably does remove microplastics from the blood, but it probably doesn't necessarily remove it from the entire body. There's probably other interesting things that come out of plasma apheresis related to longevity, but the jury is definitely out. It's not for everybody. I think there was an article recently that Orlando Bloom, everyone's favorite elf from the Hobbit series, paid £10,000, 10,000 euros for a single treatment to remove these from his blood. So it's not going to be something that humanity can depend on as a solution to this. So we're in this weird mindset that it's the individual's choice, but that is not how we solved air pollution in our country. It's not how we cleaned up the water systems in our country. We depended on a responsible federal government to create a healthy environment for everybody. And so we really need to shift the discussion around what to do. There are pushes right now. The United Nations has an alliance, a working group for a global plastic treaty. I wish them luck. I'm certainly on board and in agreement that something needs to be done on a global level. But I think that historically, we've done a lot better in regulating pollution at the federal level. Clean Air Act, Clean Water Act, signed into law by Richard Nixon. They're phenomenal pieces of legislation. They've really made positive change in this country. I'd like to get there with plastics. And I think that there are some rational, business-friendly opportunities that the federal government can start building a framework for.
Yeah, give me an example of what you think about.
A couple months ago, we were having conversations with the CEO of SC Johnson.
Okay.
So Fisk Johnson is the third generation scion of the Ziploc empire.
Yep, up near Racine, Wisconsin, close to Chicago.
Right. So he's an avid scuba diver, and he goes in the oceans and he sees plastic, and he knows that his company has benefited from these things, and so he feels some responsibility. But when he instructed his company to start incorporating more post-consumer recycled material into their bottles, they looked kind of gray or dingy and not as shiny and bright as other companies' beautiful, shiny new bottles. And they almost immediately saw a drop in market share.
Got it.
And so, there's nothing so miraculous about, I don't want to poo-poo the industry, but a Ziploc bag can be made by a lot of companies. So why would he sacrifice his family company for a principle and have it do absolutely nothing in the global theater from a plastic standpoint? So his point is, why don't we have a legislation, why don't we have a law that says all purveyors of plastic commodities have to incorporate a certain level of post-consumer recycled material? Levels the playing field.
Yep, got it.
Now you're not selling something based on your shiny bottle. It's based on the quality of your product, as it should be, right? I think another thing that we could do is, right now this planet burns 8 billion tons of coal every year. There's only 8 billion tons of plastic on this planet. So if you start increasing the number of waste-to-energy treatment plants, right now there's great examples in Vancouver, Copenhagen, Singapore. These are not third world cities. These are high examples of fine civilization, and they have waste to energy treatment plants. They get a lot of energy from these things. So waste to energy treatment plants are cleaner than coal. They're more efficient than coal. So if you start titrating out some of the coal and increasing the waste to energy production, then that becomes a solution, and you're not landfilling nearly as much waste as you have been. So I honestly think there's level-headed solutions that we can discuss.
You mentioned earlier that Orlando Bloom has decided and went through a exercise to, in essence, filter his blood to take out the microplastics. That probably is not something we're all going to rush out and do. What do we do if we're not going to go to that extreme and filter our blood? But what can we do to limit the uptake?
Our best advice right now is to limit your meat intake, and to when you're eating meat, stick to really high quality fresh meats. Certainly in our studies, venison and grass-fed beef seem to be the lowest quantity meats by 50 to 100 times compared to, say, canned meat products.
Huh.
beef sticks seem to have a lot of plastics in them. So
Okay.
we're still working on that data, and we're still working to like comparing those with vegetables and fruits and trying to create a broader recommendation. But that's really the main thing is, the processed foods probably are not that good for you.
Okay, but you also mentioned that if it's on agricultural products, if it's coming in through irrigation, I mean, should you cut down on fruits and vegetables that are heavily water based, i.e., watermelon, and say that's just dangerous? Cut back.
I basically exist off of this amazing watermelon gazpacho that I make every month.
Okay.
You will never get me bad mouthing the watermelon industry. So I don't know. I mean, there are certainly dry farming practices, and if you know, like I know different regions like Idaho and places like that may have less of an irrigation. I don't know enough. I'm out of my depth here.
Okay.
But certainly, if you can obtain foods that have lower irrigation dependence, then that might help. But I really don't have data to support that.
One thing I will ask you to do is send along your watermelon gazpacho recipe so we can include that with the story.
So good.
You don't really get many testaments for that kind of gazpacho, so it's got to be extraordinary. This may be a tough question to answer given where we are politically right now, but if I came back to you 5-10 years from now and said, what improvements do you hope, even in the challenging political environment we're operating in, what improvements on some of these things do you hope we've been able to make?
I'd like to see legislation happen. I'd like to see the establishment of, you call it what you want, a Clean Plastics Act, something like that really does take each of these pieces. Waste management needs to be done better. Recycling needs to become, functional, period. And maybe we need to consider limiting the production of plastics. I put that last because in the current administration, there's no way that gets put on the table. I know that is a non-starter for a number of countries for the plastics treaty. Certainly oil producers refuse to sign on to that. But it's probably, there will be future administrations that say, we just have to do it. We have to. Exponential growth is not a good thing. And that's what we have with plastics on this planet.
Big Brains is a production of the University of Chicago Podcast Network. We're sponsored by the Graham School. Are you a lifelong learner with an insatiable curiosity? Access more than 50 open enrollment courses every quarter. Learn more at graham.uchicago.edu/bigbrains. If you like what you heard on our podcast, please leave us a rating and review. The show is hosted by Paul M. Rand and produced by Leah Cesarine and me, Matt Hodap. Thanks for listening.